morning, guys. So this is our agenda today. So we're gonna solve this problem, the password generator problem. Okay. So okay. All right. So this is a very common um, problem, right? So you may have seen like some browsers suggesting you to generate um, strong password, right? Strong password, random set of characters, right? So that's the problem. So there are many criteria, so I came up with my own. So that's what we are going to do. There may be other better ideas as well, right? So let's start with some few things that we can actually do, right? So one thing, fast passwords and username both are involves strings, right? So and then also the um, no, you're fine. But I'm recording, right? So it's gonna go in there too. Okay. No, that's all right. So okay, so we're gonna um, right. So we're gonna take a look at and then see that like there are three groups of characters, right? So one is the character like letters, and then punctuations, and then digits, right? So and then sometimes when we see like when we create a password by manually by ourselves, right, we see this kind of requirement, right? Your password need to have this many characters and at least one number, one special character, and then one letter, right? So that's the idea of that part of it. Okay. So um, all right. So and then basically, so I added few things like users own part, and then adding it to the password, right? So kind of to make things interesting. Okay. So let's start with the three groups of characters, right? So regarding to that, do we have any matches? The three groups. Yeah. Well, the Tuesday one, right? Yeah, that was last Tuesday. So the I'm also trying to recall. So um, yeah, the pangram one, right? Right, because we got the character set from string module, right? Yeah. So that's basically that's one match. So I would say string module, not string cast, string module. Okay, string module, and then obviously the name says we will have to randomize everything. So the random modules. All right. So those are some matches. So again, there's no matching like similar matching problem, but these are the concept that probably gonna match. Okay. All right. So we're gonna basically explore a few things of the string module. So this is what we have. Okay. So we can take the ASCII lowercase um, attribute, right, for the letters. So that's what we're gonna do. Okay. So I'm going to basically print that one. So basically I'm going to import string module and also random module and then string dot, so this one basically, right? just just exploring what we have. Okay, so I'm always start with that. Okay, so you found some matching concept, well, explore what that concept has it a little bit in depth, and then this is what we are, so it's actually print this, right? So rather than thinking, okay, how am I going to solve this problem, do bit of things that further unravel your brain, right? So that's really important, especially in CS problem solving, right? Because we may not get always everything, the entire complete solution from one thinking, right? It require a train up the thoughts actually. Okay, all right. So that's that. But the thing is, if we now let's say, well, we need to shuffle this, right? So because the problem statement say it's a random password, right, generator, right? So let's see if we can shuffle this. So I'm going to go to random module and see if we can use few things, right? So it offers a lot of like operations like choice to pick one randomly from a sequence, right? So that wouldn't work, but because we need the whole thing to be shuffled, right? And actually there's exact um, function operation shuffle. So basically it's a sequence you pass. Once you pass a sequence, it's actually will take, read this one really carefully, it actually shuffles in place. So then does shuffle return something? No, because it does thing in place, right? So if take x and then actually shuffle in place, so it doesn't return anything. Okay, so we can try shuffling this one, right? So let's try that. Okay, so I'm gonna print, right? So random. So take this random dot shuffle, and then pass this thing, right? That's the sequence. Well, what happened? Well, why? Strings are strings are immutable, right? So I mean that documentation didn't properly said that, it said it's a sequence, right? So strings are sequences, right? But it has to be a, yeah, mutable sequence, right? So we can use this. So then what do we do then? So it's kind of a bit of a bummer. What can we do now? Yeah, so simply that, right? So let's try doing that, right? So I'm gonna say list, right? So basically I'm going to create a list out of the my sequence, immutable sequence. So now it actually worked, but what do we have? So we got none, right? So shuffle doesn't return anything, so we got none, right? So that means basically what I will have to do is first I will create my list over here, right? So let's say so list of um I will say random. We're gonna randomize later, right? Random letters equal this. Okay. So now I do this right here. Okay. So right here. So I'll still get none, right? So if I print it, but so just so this kind of like so the what do we call this? Like there's a common name for this kind of methods like shuffle? We learned couple of common names that we generally say this kind of non-returning functions. What do we call them? Or methods? Yeah, this is a modifier. Shuffle is a modifier. So modifiers modify. The other name is non-fruitful function. Okay, so this is a non-fruitful method. Okay, so all right. So now if you print the same list, right? So this is how you do it. You will see the randomize list. Okay, see that it's a randomized list. So every time you run it, you will get a random set of characters, but the same. Okay. All right. Okay. So now we can do the same for all the two other groups, which are punctuations and numbers, digits, right? So that part is done. How do we? Okay, so this next requirement is this, guys. Must contain at least one letter, one number, and one punctuation mark. So how do we do that? Mm-hmm. Mm-hmm. Okay. Mm-hmm. Okay. Yeah, I think that works. So basically, I would say it's a kind of manual version of creating, right? Which is totally fine. Okay. So because basically you remove one, and then once you remove, it's actually you create a group called true, and if it is there, and you basically you don't pick that one, right? So yeah, there are variety of ways doing this, but um, if something already available from Python, so my recommendation is you always go for that. So like we are saying, like don't try to reinvent the wheel, right? So if it's available, use that. And sometimes you may want, if it's an interview, you may want to ask the interviewer as well. Sometimes they say, oh no, don't use that because I want to see you manually doing it. So this can go either way. Sometimes they want to see if the interviewee has the knowledge of those stuff, right? So kind of if it is a list has this pop method, right? So pop, you can pop the one you want, and then pop returns the popped element. So you basically pop you pop let's say first element from the randomized list and put it in the password. So now it's removed. So you basically don't have to worry about picking it again later, right? So and then you adding it to the password. Okay. And then since it's a randomized list, you will also pick a random first element from that character group, right? So I think we can use that. So let's try that practice over here. Okay. So what I'm going to do is I'm going to initialize the password to empty first. Or you know what? You can actually yeah, that's fine. We'll add that later, user part. Okay. So it's empty now. But now I am going to pop the first element, the 0th element of this list, right? So password plus equal. Okay. So and then we're gonna pop the first letter. So this is a list, right? So it's a randomized list because we are shuffling, right? So dot pop, and I'm going to pop the 0. So default is actually, if you don't put any number there, the last one get popped, right? So let's formalize it to be the first one. Okay. All right. So and then you can see that if I print now the password, so I have something. But let me, yeah, so I'm printing, right? So I'm going to print the list again, right? So you can see that, right? I I popped if, right? And see that I have first element is f right here, right? But I popped it. When I print it again, then now it's gone. So it's actually working, right? So so password picked f. So let's do the same. So we can do the same for other three groups, right? And then that's clear, right? So I access the ASCII lowercase. And by the way, guys, I didn't put any criteria about uppercase letters. Most common password generators ask for that as well, right? But I didn't put there. So you can, yeah, I did not. So that's fine. If you considered uppercase letters, that's fine as well. But so I'm going to use just lowercase letters. Okay. All right. So okay, so we can do the same for other two character groups, and then we can, comply with the first requirement, having, like, having to have one, at least one from each character group. Okay. All right. So then what do I have to do? So then what should we do? So imagine now my password has at least one character from each group. So it has now three. How do we get the rest? How can we get the rest? So I have three letters now in my password. So I need to have at least eight, right? So um, how do I get the rest? Sorry. Yeah. So basically, so what we can do is, right. So I basically now need to randomly grab the rest of the characters from all, right? So basically I need to combine all of these, the three lists, right? So right now I only have one, right? But I have the digits list as well as punctuations list too. So I need to combine all of these uh, three lists together, and then first I need to shuffle it again, right? And then pick a random, um, pick randomly from, I think I can pick from, sorry, once I shuffle, that's random process, I can loop it over and then get the characters I want. Okay. So that's what I'm going to do. So I'm going to try doing that just for the for loop. I'm going to only use random letters over here, right? So for I in, sorry, uh, and the range. So range should be, so I only have three characters. So let's say here, it's 80, sorry, 8, right? So 8 minus 2, it should be 8 minus, um so I only have 3, right? So this should be 8 minus 2, right? And then basically I am going to add, so I remember, guys, I'm not concatenating the rest of the tool is, right? So we can do it at the planning stage. This is still understanding. So I'm going to basically add those characters to password plus equals, right? The um, from the beginning of this. Okay. All right. So the password is this one. Okay. So I got this one as the password. Okay. All right. So looks working. So only need to do is I need to create the other two lists and then concatenate that and shuffle the entire list before I run the for loop. Okay, so let's write our plan. All right, step one. What are the inputs? Inputs. Yeah, so user part, right? Length, right? Right, length. Yeah, yeah, length. Okay. So step two, we're gonna actually get the character set, right, from the string module, right? So I would say, yeah, get a list of letters from string module and I'm gonna write also randomize this and randomize it. Okay, so this line has three actions, so converting it to a list and then two actions and randomizing it. Okay, so I'm gonna name this as random letters. Okay, right, three. So we're gonna do the same for digits. So there should be a list of. Well, is it a list of or the list? Either, yeah. Yeah, predefined, right? Yeah, the list of, yeah, I'd say the, yep, the list of digits. And oh, and then basically this is random digits, and then it's for same for the punctuations. For step 4, get the stop punctuations. Okay. All right, so now basically so we can write what all together, right? Pop the first item from each list and add, oh, before that, right, we need to initialize our password, right? So step 5, initialized the password to empty, like this, and then pop the first item from each list and add it to the password. Okay. 7. So basically the random part is done, right? So oh no, sorry, the complying with the minimum requirement is done. So now basically since we pop that character is not there anymore, and we can combine all three and then shuffle it. Okay, so combine all three um, list and shuffle. Okay, so it's now basically we scramble them together. Okay, so 8. Now we're gonna loop over and add, right? So for index I in range from well 0 to 2 less than the length, right? Length minus 2. Okay, and 8.1 add ith index of the so I think this should be all characters, all characters to password. Okay, 8 sorry 9, step 9, we're going to return now, right? Return pass basically well I'd say add the user part. Or add the I mean add the user part to the parser, right? So this one user part, and you can do it in front or in the end, doesn't matter. Okay, I didn't restrict anyway. Okay, to the password, and then step 10 return password. So this is our plan. Okay, okay, all right. So so let's write our function, right? I would say generate random password. Random password. All right, so it's basically returns a random password based on the criteria using so the so inputs, right? Username, so user part, and then this, right? Okay, and length, there's a default value of 8. Okay, okay, all right. Oops, to close it. Okay, so we're gonna create this list. I'm gonna use this, guys. So we already have this, that one, and then basically shuffle it like this. So So that's this one, get the letters. And so basically this step is this 2 lines. Okay. And then step 3 is the other. So I'm going to copy paste, and then instead of punctuation, sorry, so this should be, let's say, digits, right? So digits. Okay. And this will be basically digits. All right, so this is going to be digits. Then you're going to shuffle that one as well. Okay, so basically this is what we are using, right? Shuffle. Okay, and the ASCII lowercase here and digits here, and then the last one we're going to use punctuation. Okay. Okay. So so the third step is fourth step to get the list of punctuations. So we're gonna I'm gonna copy paste and change, right? So punctuations, and so right here, so this should be punctuations, and punctuations, and it's gonna be whole thing. Okay. Okay. All right. So now we need to pick the first letter, right? So this again like this one, right? See that? So I'm gonna copy paste this. So initialize the password. So that's the step 5, right? Initialize the password, and then pop the first item from each list. So which is what we have done as an like manually, right? Okay. Okay. So so we can now do the same for from each of the other two lists, right? So this is from letters, right? And we need to do it for the digits and also the punctuations. So I'm gonna copy paste and then add that. Okay. So this should be digits, and this should be punctuation. Okay. Okay. All right. So by this time we have 3 characters randomly picked from each group, and we need to basically add the rest. To before we add in the rest, basically we need to shuffle, like combine all 3, right, into one group. So let's say all characters stars. So you're gonna concatenate all 3 lists, right? So remember we learned the concatenation in module 8, right? The type module, right? So we're gonna concatenate all 3 lists, and then into a 1, right? And then so what do I need to do? I should shuffle this, right? Should I do this, or like, can I do this? Why not? Yeah, it's written none, right? So if I do this, right? If I do this, this will be non-type, will not be the whole list. So don't do that. So basically leave it for the next operation, right? So leave it aside, and then just without assignment, call it on all chars. Okay. So all chars will be shuffled now. It's basically it's going to crumble each 3 groups together. Okay. All right. So now we are ready to loop over and then add characters, right? So can we avoid the loop? Yeah. So I mean, there are functions that we can use from a random module, right? say this one, like the sample one. So yeah, the problem is this: it will actually, so if you pass our list to get a sample, let's say population is the sequence, which is our old chars list, and k is the portion we want, like say length minus 2, right? But the problem is it returns a list now. Yeah, and then you still have to loop over, and because it's not a character, like it's not a string, right? Yeah. So the thing is, yeah. So if you try to, basically, you cannot convert a list, like list of characters directly to into a word. You can't do that. You cannot. So, for example, let's try it over here, right? Let's say I have this, right? So, for example, print. So we are trying this out. Okay, str. Okay, so I'm gonna basically do list. Okay, and I'm gonna say Python. Okay, so what you will get is, see what we get. So what's going on? Wow, I didn't actually. So I need to actually call it in the main programs. Let me cut it and do it here. It still didn't run. Okay, so this is in main, right? Okay, there you go. See that? So I will not get a word back. So that's how Python does it. So it's this is, see, this is still a string. So 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 let's see. Yeah, so basically this is the list of strings, right? So when you convert it, I think it should um make it a, that's, no, no, no. It's list only can take a sequence, another sequence. Oh, any sequence basically, including a list. So basically, so this is why it's still a list. That's kind of, that doesn't make any sense, right? So, but this proves that you can do this, right? But that doesn't, yeah. So, I mean, yeah, I don't know. They probably should facilitate this, don't you think? Yeah, right. It should reverse, right? Right. So, but then there's join function in the string module. You can join, but that's what we're gonna do. We're gonna concatenate. Okay. So basically, um, well, let me put. Is it still okay? Print type. Should it, like, just want to verify whether it's a list or, well, it's a string. See that? It's a string, but it's it has the whole thing is it encapsulates the whole thing list as it is, yeah, into, yeah, but somehow this doesn't print the last quotation. That's why kind of a confusion earlier. We didn't see the quotation, right? But if you see this type, see that it's actually a string. So it's a string, but in the form of a list. Yeah. Okay. Yeah, we can use join, but we can, it's simply same similar to concatenate, right? So we're gonna loop over. Oh, you mean join and then does it work? Okay, so let's try join. Str. So I'm gonna say, like, let's try it out. Okay, so password, um join, right? And then Oh yeah, password equals. Oh. Oh, okay, okay. Um, so so password dot join, right? Oh no, no. Oh, okay, okay. So this whole thing, and then dot join. Oh, okay, okay. So this one dot join, join password, or just this? No, right? I think. Well, yeah, yeah. Password dot join, and then yeah, I think that should be that. And list Python, right? Yeah. So let's see print password then. So we should have, let's see. Um, yeah. Well, it didn't work, right? Looks like it didn't work. Yeah. Oh, okay. Join list. But anyway, so let's do the loop way first, and then we'll figure out that later. Okay. Okay. So yeah, but yeah, I think it should be possible. Yeah. So we're gonna basically loop over now, and then add up to. So this we're gonna do this one, guys. Okay. So we combined all three. So now we're gonna loop over. So for I in range, and it's 0 to so the length minus 2, right? So length minus 2, and then basically, so it's already shuffled. Don't worry about randomizing, we already randomized it, right? So you're gonna basically add, so from here to our password, right? So password plus equal this one, all chars I. Okay, the ith character, right? So see the I. So and then, so yeah, that's it. And then what we have to do is in the end return, right? So I'm gonna update the password with the user part, right? Password plus equal, sorry, plus equal. Well, okay. I think user part should come first. So um, yeah. So I'm gonna say equals user part. That's my choice, guys. So you can do whatever way you want. Plus password. Okay. So it's kind of reassignment and return password. Okay. It doesn't matter whether you put the user var to the end or front. I didn't. Um, I was not particular about that, right? All right. So let's run this. So I'm gonna make the length 16. So print and user part. Let's say like there's another requirement, minimum length requirement for that one. We're gonna add that later. Okay, guys. So let's say CCSF, and then length I'm going to say 16, and we'll get a one. See that CCSF, and then this is the random part. Okay, and it has a character, has the number, and also has a punctuation. Yes. Oh, okay, okay, equal to that. Okay, thanks. Yeah, but I will that into a different function. Okay, so yeah, so so that means we don't need a for loop, right? Yeah. Okay. I think yeah, that's what join does actually. Join can do big part chunk and yeah. So all right, guys. So and that's that. That's all. Okay, so so let's quickly go over the 5 questions we have. So I will add the improvement so later. Okay, so what we need to do is basically we're gonna go through this list, and then and if the user picking that one, and we basically say you're gonna return a error message. Okay, so you say user enter password and it's in this list, so we reject that option. That's all. So it's a if else in our function. Okay, all right, write a statement in your in you use in your code other than an assignment statement. Well, what is it? Return statement, right? So as in this one. Okay, write an operator type token you use and the respective operands in your code. Operator type token plus equal, right? Plus equal, or even plus, this plus, right? Let's say this plus is operator. So what are the two operands? User part and password. Okay. Write two punctuator type tokens you use in your code. Punctuators. The colon, this colon, right? And which one? Pound sign, yes, that's one. And it's quotation also, right? Also punctuators. Okay, but the bracket is not here. The bracket is actually a operator. Okay, all right. Write a formal and actual parameter you use in your function. Formal parameter. Formal parameter. Yeah, user part and length both are formal parameters, right? And then the actual parameter is right here at the call, right? So this one is actual arguments and 16. Okay, write a global and local variable you used. Okay, so what's the global variable we used? With respect to our function, uh, um, this one is global, password is global. Okay, because it's in the main program, right? And we are calling our function within the main program, so it's the main here is one step away from the function, right? But I think the best one you can give is this one, this global variable. It's a global variable. It's actually, but it's an internal variable coming from Python. It's global though. Okay, so that's that. And then the local variable you used. Well, this password, this one and this one become local, right? The formal parameter you passed to your function become local variables, and then the random letters, random punctuation, all of those are local. Yeah, so we're going to take our break now. Okay, okay, so now we are continuing this module, right? So this one, um, the module 13. See this one right here, the cryptography. So the video now we're going to watch is going to be related to cryptography. Okay, so let me open it. So it's a really cool video. You guys should watch it again. I think I have to refresh. Let's see. It's in here. Yeah, how RSA algorithm works. Okay, so this, so I just published it. Okay, So refresh your module. So this one, I really like this, the videos from this guy actually. The channel is called Veritasium. Yeah, so Derek Muller, right? So that's he's the guy. He he actually, these are sometimes complex math and things. He really nicely explained them. I guess I would say anyone who, you know in high school understand the concept. These are sometimes complex math and even quantum mechanics things, because he's a physicist himself. um, so his explanation videos are really like factually verified, and he also influencer now, kind of. The subscribers are like 200 million, I think, the number of subscribers. So let's watch his video. So this is about cryptography, and it's kind of revelating something that can happen when the quantum computing become a reality, right? So something that serious can happen. But he also mentioned how this RSA algorithm works. So it's a long video, it's 25 minutes, so we're going to watch only 6 of it. Okay, so let's watch some. So that's the question that they are trying to answer in quantum computing right now. So that problem is not solved yet. So that's why they are doing research right now. So it's a superposition of all possible answers to find the answer, to get only the answer you want from that many combination is not solved yet. So that's what they are doing research for right now. Anyway, so let's go, and then but I highly recommend to watch the entire video, and it's really interesting, guys. Okay, so and then may gives you other his other videos as well. They are really cool. Okay, and then factually based as well. They are not, you know not just opinions. Okay, all right, so let's go. All right, so I think we solved the problem, right? So I'll add those two solutions. So let's continue our lesson, guys. So we were over here, so we're going to start with this one. All right, so these are the three goals of information security. So we should have confidentiality, right? So we only disclose information only to the authorized people, right? And then that's why we have, like, those like on like lodging, like, bank accounts, like online access to them, only the user has access, right? So that's one. The integrity, basically, we should not allow um, basically someone to change information illegally, right? Like, for example, let's say news agency posting a news, and then someone go and alter it for, let's say, sinister purpose, right? That should not be allowed, right? So that's the integrity. And availability, basically, so authorized people should be able to access the information they want and whenever they want. Okay. Okay. So security vulnerability is basically a flaw that can someone exploit, and then get access to, let's say, computer system, right? And if that happen, we call it a data breach or security breach. All right, so simply called a hack, right? And there was several you may have heard, right, several examples. um, this one, there's the Sony picture thing, right? That this picture was never aired actually, right? So um, so I think the North Korean based hacker group did that, right? So they lost actually a lot of money because they were ready to actually launch the film, but they couldn't. um, and then there were other, like, like Chase in 2008, and then maybe after, even afterward, lost, um, got breached. So in what happened with Chase was, the person left the computer like this, in a coffee house, and went somewhere or to the bathroom, and then at that moment, people got in and have stolen the password. AT&T in COVID time lost 70 million social security numbers, and they admitted last year that this happened, right? Yeah, so the basically, try to hide this, and those things happen. In the end, basically, they also lose money, and in the end, customer lose money, because they end up paying, like, giving customers, like, after lawsuits, like, for example, credit monitoring and things like that, right? But in the end, they build that bill also to the customer, so the customer getting hammered in this, right? In both ways, right? They lose their identity as well, and also lose money. Okay. So let's go to virus and malware. And this is a common topic that we also heard, right? So computer viruses, right? And now let's quickly play this animation. It's So we have a infected computer, and the person sending an email, and then a virus get attached to that email, and then goes through with the email. So modern email providers actually scan emails for viruses, which is a good thing. But but imagine the person who opens that email, or the file in the email, now gets infected, and then they are now, those computers may infect others as well. Okay, so that's one way a virus can spread. Okay, all right. But also, right, like, people advise against, like, untrusted, like, flash drives, right? Let's say you find a flash drive on the floor, and then you pick it up, and then you try it on your computer, and that could probably be someone trying to steal information, and by infecting your computer, right? So it's really, a big no-no, like, trying a storage device that is untrusted. Okay, all right. um, so one of the objective of virus is to basically hijack your computer, and then, do some organized crime, like, denial of service attack. Okay, so what happened in a DOS attack, basically? Yeah, 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 yeah. So in the end, what happened is basically this. So there is a limit for a particular web server can serve. Right? Let's say it's 500. Right, 500 simultaneous page requests it can serve. That's the limit. So what happened is the DOS attacks is, so the attacker hijack a lot of computers, that computer send, all of those computers send a, page request to the server. Now the server get overwhelmed, pretty much what we see in with our desktop, right? So it gets stuck, the server gets stuck, now can no longer serve the page. Basically now the website is not working. So that's what happens. So that's the DOS attack, because, again, web server is just a server like our computer, right? It's a computer, right? Basically it's a machine like our computer. So it also has a limitation to do thing, right? It can also get stuck. So same way our Windows get stuck, we'll have to reboot, right? So, well, they have to restart the server now. Okay, so that's actually interruption, right? So that's one way of And you may have heard, right? So these days, I think Ukraine get a lot of DOS attacks. Ukraine government website. Um, I last year I heard Estonia, this one of another small Baltic nation, right, getting attack. Estonian government getting attack DOS. Well, you know the obvious player, right? So this the big guy, the Russia, right? So the, those those people trying. Okay, so I mean they don't, you know, admit, but you know usually those things goes towards them. Okay, so and then there are some examples of big viruses, right? So my doom and so big. So there are a variety of malware types. So one is the virus. Virus actually usually spread through emails or files, through files, infected file, right? It's kind of similar to actual, like, you know, biological virus. Okay, so well, the same way virus, biological virus spread from human to human, right? So the computer virus also spread like that. So worm is basically it's a malware that spread without a file, so without a host file. So think of, it's actually travel through the net, internet, like a worm. Okay, so and Trojan is basically it's a malware that we um, install with the software that we're going to install. So now we also install the Trojan. So it's the idea of Trojan horse, right? So remember this Trojan horse story, right? So it's something like that. So they say it's happened actually, right? Maybe it's a legend as well. Um, but it's some smart idea, right? So may have well may have happened, right? So yeah. So usually people use Trojan. We sometimes call backdoor agents. Sorry. Oh yeah, maybe yeah. But yeah, the Troy is it's a city, right? Oh really? Okay, Troy. Okay. So this is BC era, right? So the Greek Empire, I think, right? Yeah. Not even Roman Empire. I think even before that, right? Yeah. Even before Roman Empire, I think. Yeah. So anyway, so adware basically put advertisement without your consent, right? And spyware simply spy your activity and report it to another entity. Okay. So antivirus software and firewalls. Okay. So to get rid of or to get defense from antivirus and sorry virus, so we have antivirus software. So modern operating system usually comes with these days. For example, Windows Defender is one, right? It has both the firewall and an antivirus software together, right? So the there are some examples over here, right? And there is another one, right? So with M, what is that? There was a antivirus software starting with the name, so letter M. Mm, the founder actually committed suicide, I think. Um, McAfee, yeah, McAfee. He committed suicide, right? Yeah. 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 So he was accused of sexual harassment with kids and right with like child abuse, and he actually but before he fled to, I think, yeah, he changed even the citizenship, right, to one of the island nation. I think I forgot which one though. I think it's probably Seychelles. So um, yeah, I mean, he found, and then he actually before that he sold McAfee, so it's 60 something million dollars, and then he actually fled to a different country and changed the citizenship. But I think he, so yeah, that's his name is McAfee, right? In EMS. Yeah. So, so the way virus detect is there are three ways. One is virus signature. So it's a similar thing that our body defend against virus. Like for example, like when we get chicken pox, right? We usually don't get the second time because the body identify the marks in the virus casing, like the outer cell body, right? And body remembers that, and once a new virus comes in for the second time, it's now can detect easily because it also has a signature in the body's memory, right? So some immune cell keep that memory, so and quickly react and kill the virus. So same idea here. So we have the signatures. So it basically it's a piece of code, right? Virus is a piece of code. It's binary, but it's uniquely behaving. So if you can take that piece of code, that's the signature. So antivirus software can scan for that pattern of bit pattern, and if it can find that bit pattern, and it can basically say, okay, this file is actually infected. So the problem is there's a big weakness. If the virus is new, we don't have protection, okay, because it's not in the database, right? And the other issue is if your virus software is outdated, and then you may not have the most recent database with the virus software, and that's one big reason that they say you have to keep updating. You should have your latest version of the virus guard. Okay, that's the reason actually. And the other way is you can basically, if there's a suspected virus, and then you basically put it in a sandbox. So basically the infected file that you suspicious file, you put in a sandbox and let it run, and if that behavior is suspicious, then you can basically conclude it's infected file. But the problem is some modern virus knows that it's in the sandbox, it's now keeping quiet. Can happen as well. So the most advanced technique is the heuristic analysis. Basically, like routinely, like check for malicious behavior and then conclude. But the problem is it may well mark uninfected files as infected. Okay. All right. All right, this is I'm gonna skip this topic, guys. So let's you guys also know this topic, right? So two-factor authentication. So you have let's say you have a user account and protected by password and username, but you have another way of, so once you um, basically log in with the password, right? And then it also asks this second code that's sent out either via a call or a text message. So that's the second method of authentication. So both combined gives you the access. I think modern banks online access, I know Chase does that these days. So you you cannot just use the password, you also need the code, either called or SMS received via SMS. Yeah. And there are other ways like pass keys. Um, Google now allow, I think, Windows PIN, right, as the password to verify. So I think they call Windows Hello or something. We can also create. There are passkey apps as well, right? Third-party apps. Um, so that you can verify further as well. Okay, sorry. All right. The one of the common way people um, steal passwords is through phishing, right? So basically, it's an imposter. You create an imposter website out of a legitimate website, and you can easily do that. Basically, so client side code is already visible in the browser, right? So you copy that code and then create a new web page with the same code. So now you have a copy of the, let's say, Amazon, right, website, and then you can do many illegal things with that. So because you can use that page now as the imposter page to steal information. Okay. So, and if you play this one, this is actually Bank of America, and you can see though it's not actually Bank of America, right? It's actually AAA. Remember we saw this earlier, right, in the internet discussion, right? So so this is not Bank of America. It's actually AAA. So this is the disguise. But people only, some, people usually have low attention span and then don't pay attention to this and say, oh, this is Bank of America and I'm actually logging into it. So you actually put, um, you basically enter your information to that, right? So usually get it through an email like this. Dear customer, here's the link that you should reset your password. And here is the link. And that's how you get the page. So that's the phishing attempt, right? Usually we get phishing requests via emails. I mean, it's kind of this. At one point, I actually got an email. It was so disguised that I actually almost got into the trap. So it was from David G, which is the dean here at Science College, right? So his name was there, and then there's a one letter miss, and then different between his actual CCSF email with this one. He asked money. Hey, Indika, I think probably someone inside because I knew him very well. I still don't know him very well. So we basically, because it was the STEM building and I meet all on the first floor, his office was there. So we were teaching there. So regularly meet with the person, right? So that's how I got to know him. So I got this email, hey Indika, I need cash, 300 something, really urgently. Could you buy a gift card and send me the gift card number? So there was a store, I think the Gap store, something like that. So and then I'll repay you once I meet there next week or something, right? So I almost, so then I actually, what I did was I used, I sent an email, I replied him, and he replied back as well. So so basically, then I found out when I start typing his email, the Outlook suggests actual email, right? Then I saw that actual email. I saw found the tiny difference. So then I actually, that's the moment I stopped actually. But he actually replied, "Hey, do this, and then I still need this money. I still have it." I forwarded him the thing, and he actually then uh, um, basically asked other people to not to do that as well. So this can happen to anyone, right? So that's, yeah. So this is really famous as well, the Nigerian scam. So it's like, you get an email, right? So I have this much wealth, but it's, I cannot get it out of the country because country in a war situation, right? War torn country. No, no, it's actually, well, sometimes these requests coming from Nigeria, many. So like sub-Saharan countries, a lot of them. And then right now, Nigeria is trying to clean its name, because it's the name is Nigerian scam. It's attached to the country, right? So it's embarrassing for a Nigerian, actually, right? So they're actually trying hard to eliminate those scammers inside the country, actually. There was a nice PBS program, actually. At There was one time one US person took 400,000 in cash and went to this one of this African country, and you know got out with the life, just bad, like he saved his life somehow. So but he lost money. So so there was this scam called black money. So they say, okay, the money got damaged by paint, so it's black now, so we need money to clean it. So there's this cleaning agent, it costs money, can you send, and we'll give you this much of a cut from that total money. Okay. So black money scam, so there are a lot of these. So these are also spam call, spam emails. If you check some spams, these are the type of request. But still get people get caught in these scams. All right. So we're gonna I think we can do this one. So this is, yeah. So we're gonna go over digital certificates later, next week, guys. That's our last day of class. But I'm gonna go over this one. The symmetric key cryptography. So this is basically, we just saw, right? So the if you take a look, right? So there's a single key shared between both the receiver and the sender. That's why it's called symmetric key. It's one key. And then how do we do that? It's probably pre-arranged, and then that's sharing, right? So and then basically you encrypt using that key, and then so it can safely travel through internet because it's scrambled, so encrypted. And then receiver has the keys, receiver use the key to decrypt. Okay. All right. So that's the symmetric key cryptography. So the problem with symmetric key cryptography is that we saw in that video, right? So if the two entities are really distance apart, there's no easy way to share this symmetric key with the receiver or sender, right? So that's a big problem. And that's the problem, actually, that public key cryptography solve, or asymmetric key cryptography, right? So the RSA algorithm, right? So that one basically, so you you share the public key with, but it's public, so anyone have access to that, right? But to decrypt, you need the private key as well. So that only basically, only one of the two keep it. Okay. So in this case, receiver has it. So if you play this one, right? So you have the public key. You can actually encrypt using that public key, right? So basically, so receiver, let's say receiver is the bank. Bank create the both keys and send the public key to the sender, right? And then basically sender use that to encrypt and then send it. Okay. But to decrypt this one, you need both keys. Okay, that's the idea. Okay. So the hybrid model. So now you can send the symmetric key encrypted by RSA algorithm. So basically, this is how the modern login, user account login works, right? So you authenticate using password, which is the RSA, asymmetric key cryptography. So public key cryptography. So now a session is prepared. Now there's a secure communication line between the two. Now you can actually send the symmetric key for further secure communication. So that's how the user account login, and then the rest of communication works in secure websites. Okay, so that's the actually hybrid technology. So we're gonna do this one, guys, next week. So let me go over the two things due in this module. Okay, so which is this one, right? So one is okay, which one? 13. Oh, this one. So basically, so you pick up a social media website. Um, it can be a lesser known one as well. And then you have to find the default privacy settings for that website. And then you need to learn how one would change that privacy settings. And then in the discussion for you have to write these things: in name of the website, that website default privacy settings, in a sentence or two, and then quick step-by-step instruction on how to change that privacy setting. Okay, and then once you see the reply, once you post, reply to someone else post with helpful comment or feedback. Okay, so that's the discussion, and the assignment is basically this. So it's the SQL injection quiz, right? So it's a quiz, and then you take the quiz and then answer those questions. Okay, so I would say this assignment is a scoring opportunity. Okay, so because this is not a programming assignment, right? So and we also watch a video on that as well on the topic. Okay, all right, guys. So let me open the problem today, which is this one, factorization. So this is basically the problem that we saw today, right? So the prime factorization. So this is a really interesting question. It has I would say this is one of the difficult question um, that so I published it, guys. It's in module, which module? Module 13. Yeah. So but the first part is straightforward, but if you try the rest, you'll have to use this code. Okay, so all right, so and then read through this one. So I put helpful comments, what to do, and then explaining as well. But all you have to do is your function name. You basically, to run this code, pick your function name and replace this wording with your function name. That's it, and the rest you can run as it is. Okay, and this is the list that I stored for you, the semi prime numbers, the prime numbers that could multiply together to from sorry the numbers, these numbers can only have two prime numbers. Those are the two factors of those. So they don't have small factors, right? So they have two prime factors that are, that I found earlier, right? So you need to find them, right? So the idea is you fill out this table. Okay, so I already so right here I actually ran this. So this is my code. So it took it's a lot of time, but this one looks like a outlier. So if I actually, so this is how I actually you should graph this one. Okay, so I go sorry, go right here. Okay, so let me show you that. Okay, for now, so I'm going to delete these two tables. Okay, so both, so nothing in there now, right? So I'm gonna, oh, by the way, guys, a compile explorer will not work. They will time you out because this program take several minutes. This one took actually more than 30 minutes to run.
So you would use the other.
You can use your, you have to use your own, like, you know, local
Oh, I would
IDE.
use actual local.
Yeah, local IDE you will have to, but you can still post the code via compile explorer, but they will not run this. Like they will run only first couple of ones, which is faster, right? This probably these three, and then they'll stop from there.
So we implement similar what we've done before, like the understand, the learn, the match, implement stuff like
Yeah,
that.
yeah,
And then the
those
main
things. Yeah,
is where we implement your code with all the specifics,
yeah,
and then put that
yeah,
into the actual
yeah.
windows.
So you'll have to print something like this. So let me show you how to plot. Okay, so you're gonna copy, like, so you can print like this, right? So I'm gonna leave the last one. Control C. So this is PyCharm. This is my local IDE. I use PyCharm, and then I'm gonna go to Desmos. I have given you the link. Okay, just dump it here like this. Okay, so here is the plot. Okay, all right, just copy paste. That's it. So now we need to fit this, right? So the thing is, we are proving that this is exponential growth. So we are proving that this factorization cost exponentially growing function. Okay, so to do that, so go over here. This is how you actually, you know, fit a curve in Desmos, right? So take y, so see the variable y1, right? So y1, okay, and then not equals, it's this one, roughly equal, because we are fitting. Okay, and then I ask you guys to fit, I think I asked you guys to fit, where is it? Okay, um this is, yeah, 2 to the k by 2, so this would be y1, right? So 2, so it's that this is exponential growth actually. Okay, so in this case I'm actually, yeah, I'm inputting, outputting, right here, this is the this is the time, and this is the bit length. All right, so this is like 50 bit length, 50 length of the bit, right? So I'm plotting that. So basically, to plot this, so basically this is 2, so I'm going to say put a times 2 to the power, sorry, to the power y, so this is y, right? Y1 by 2. Okay, y1 by 2. All right, oh, I need a constant, sorry, so this side plus c. Okay, oh, I don't know why it's actually, did I make a mistake? Oh, sorry, this should be x1. The mistake, there you go. Okay, so this is the fit. Okay, so, and you can see that it's actually this r square really close to 1 means a really good fit. Okay, so this the r square is this is a statistical parameter, right? So it's close to 1 means it's really good fit. Okay, so, and you can see that this is the pattern, right? So now what you need to do is get the, so this is 56, right? Now you have the function, this is the fit, so these are the a and c and e, all those, right? Sorry, a, yeah, a and c. So you plug this to this equation, this is your fit, and then you plug, I think 2000 something, right? Did I say? Yeah, this is the, so the RSA current version 248 bit semiprimes has 248, so k is 2. You plug that, and then you will get in seconds a time. So you convert it to years, you will see that whether it's in millions. So you will get a million year value for k equals 2048. Okay, so that's the improve, you know, the second part of the question. Okay, guys. So, and you can see that it's exponential growth, right? So this is still 250, right? So sorry, this is the x-axis, right? and you can see that it's really big, right? I mean, you can see that, right? Still growing, but we are still less than 200. So imagine how much would that be if we go to 2000 something, right? So this is going to be a really big value. So it you will get millions of years. Okay. All right. So that's that, guys. Okay. So so that's how you fit. Okay. But I have given the code you need to get that table. Okay. So this is the code that you should take. Only you need to change is plug your function name. That's it. Okay. All right. All right. You're welcome. See you Thursday, but so see you next Tuesday. But we'll solve this together. Okay. So factorization is not that difficult. It's a simple factorization algorithm, and it's not the advanced algorithm they use. So it's a little bit more efficient, but we are using the simple mathematical factorization algorithm. Okay. Tuesday. Sorry, Tuesday. Did I say Thursday? Sorry, Tuesday. It's our last lesson, and then we're gonna have Thursday. We'll have our practice exam.